So in 9.2, we're going to be doing confidence intervals and hypothesis tests. So the difference here is that we're going to be dealing with two proportions. So the process is going to be the same with PRTC. So the null hypothesis is always equal. That's similar. So we don't have a claim. What we're doing is we're actually just comparing two groups to each other. Okay. So when I do PRTC, what we're going to do is we're going to start by defining two different parameters. Since we're dealing with proportions, we'll have P1 and P2. C. Nasal spray for vaccine following statements presented, trial involving 1602 children. So there's our N1. 14 of the 1070 received the vaccine developed the flu. So there's our successes 1. And then there's our N1. Okay. 15 who got a placebo, that would be our X2. Out of the 532, that would be our N2. Test the claim the experimental nasal spray decreases the chance of getting the flu. Okay, so this will be the probability of getting the flu. Oh, no, not with an E. 1 second. There we go. Probability of getting the flu. And this would be with the treatment. Versus the other would be the probability of getting the flu why do I keep putting an E on it? Sorry. With placebo. Our requirements. Both need to be done randomly. It says a trial. Doesn't say anything about them being done randomly. So basically, we must assume that these people were put in groups randomly. Second, how do we get normality? Well, I need at least 5 successes and 5 failures, but this time it's for each group. Okay, so our successes must be greater than 5. Well, our first successes was 14, which is greater than 5, and our second successes was 15, which is greater than 5. And the failures must also be greater than 5. That's the rest of them. So that's the 1602 minus 14. So what is that, 1588? Which is greater than 5. And 1070 minus 14. So how about 56? Which is greater than 5. So those are our requirements. So PRT, what test are we running? Well, the fact that it said to run a test and that it says that it decreases means I'm not running an interval. I know a lot of you were trying to do that on the last test. Be careful. If it says to run a test and you do an interval, you're getting yourself in trouble. We're going to do a 2 proportion Z interval. The fact that we're doing, see, I just did a Z test. Okay. So the fact that we're doing a test means we're going to have hypotheses. What's our null hypotheses? Well, that these two proportions are equal. We assume not. We assume that they're equal to each other, right? Alternatively, if they don't say anything, we do not equal to. But here it says the spray decreases. So this says spray, which was in group 1, gives me a lower proportion of getting the flu. At this point, we're going to do some heavy lifting, but it's going to be on our calculator. So in the calculator, menu, statistics, tests. This is not new. But we are, instead of doing a 1 proportion, we are going to do a 2 proportion Z test. How many successes do we have? What was it? 14, 1602? How many successes in the second group? 15 out of 532. Our alternative, less than. By the way, this at this point is, if you forgot to state the hypothesis, this should remind you. Don't forget, they're going to ask for a hypothesis. You need to state that in your test. What do I write down? If you're not sure, write it all down, but all we need is the test statistic and the p-value, no degrees of freedom on a proportion test. So z, negative 3.358. P-value is pretty low, 0.0004. Compared to an alpha, did they give me an alpha? If they don't give you an alpha, use 0.05. PRT C. How do we write the conclusion? P-value is low if or no since the p-value is less than alpha, we reject the null hypothesis. Don't just say that. What is it? We reject that they're equal and conclude that the first group is significantly less than the other one. Our results are significant. That's how you do two proportions. Let's try a couple more. Radon is a gas produced when radium decays. It can enter homes where it has become a health threat. Among 186 homes in Hyde Park, New York, 16% were found to have an unsafe radon levels. Among 237, 19% were found to have an unsafe. So the one that's different about this one, and they just want to say test the claim the two regions are different. Okay, not greater than, not less than, just different, and it does say to do a test. Okay, so the difference on this one is that they are not giving me the number of successes. Okay, so we're still going to do P1. This is identify the problem, and it's the proportion of dangerous homes of unsafe. I'll just put homes with unsafe radon levels. And we have two different places. Hyde Park and proportion of homes with unsafe radon levels in orange. Okay, so the idea here is that we think, oh, one of these is a nicer area. Hyde Park is kind of an uppity area. Lagrange is a little less. So, you know, maybe they have a higher proportion of radon that hasn't been taken care of, and so those people are at risk. You might have a lawsuit here if people haven't kept things up to code. Okay, so what are the requirements? Well, this data had to be collected randomly for it to really generalize. It says 186 homes, 237 homes. We have to assume. But if they got 186 homes by picking 186 homes that are in the poorest part of the neighborhood, then you would have bias. So you need randomization to generalize that. That's all we're saying. Second, how many successes? We don't know. But I do know we can calculate that. So our successes is going to be that n times p hat. The thing is, we're going to have to do this twice. So n hat, p hat 1, and 2, p hat 2. So 186 times 0.16 tells me, now we did 129.76 homes. We would say that is 30, which is greater than 5, right? The other 19% of 237. We did not have 45.03 ohms, so probably closer to 45. And this is the number of successes, greater than 5. How many failures? Well, I could actually do the complement, so I could do, what is that, 84% times 186? Or I could have just said, well, look, if 30 homes, right, if 30 homes were whatever success, whatever we call it, I don't know if that's unsafe, I think it is, then 186 minus 36, the other 156 would be 5. So that's a couple ways of doing it, but 156 is greater than 5. If 45 homes were unsafe, then the other, subtract that away, where's that, 192? And that is the failures. PRT, we're dealing with proportions again, so a 2 proportion Z test. Stating my hypotheses. We start by assuming not. We assume equal. Alternatively, it just said different. That doesn't say one is worse. We're just saying we think there's a difference. Let's run this test. Menu, statistics, tests, 2 proportion Z test. How many successes are we looking at here? What was it? 30 and 45. 30 out of 186. And 45 out of 237. And I don't need to mess with it this time. Not equal to is what we're going for. What do I need to write down? Negative 0.764. P-value 0.445. And did they give me an alpha level? If they don't, we use 0.05. How do I conclude from this? Well, this time the p-value is not low. So since the p-value is greater than alpha, instead of rejecting, we fail to reject. That the proportions are equal. Conclude nothing. We have insufficient evidence. We have not significant results. Okay. Now, how do we deal with proportions? Okay. So when I do a proportion, it's always on the difference between the mean, or between the proportions. Okay. So what we really come down to is if my interval, okay, this means is if our interval basically contains 0, so if it goes from negative to positive, then that means zeros in that interval. There is potentially no difference. If the interval goes from negative to negative, there is a difference. Or if it goes from positive to positive, there is a difference. Okay? I'd like to take that a step further and say, well, if it's negative to negative, if I did P1 minus P2, and it's negative, less than 0, then that implies that P1 is less than P2. If the difference is negative, then that means the second one must have been bigger. When I subtracted them, I got negatives. If I get all positive, then P1 minus P2 greater than 0, that implies what? P1 this time must have been greater than P2. Why? Because when I subtracted them, I was left with all positives. Okay? So, but either way, both of these implies there is a definite difference. Okay? So among 5,000 items randomly selected baggage, so that is our sample size 1, 22 were lost. We're calling that success. Among 4,000 randomly selected by delta, 15 were lost. We're going to do a 95% confidence interval to estimate the difference between the means, okay? And then decide, does there appear to be a difference based on this, okay? So, P, what are our portions? Well, the first one is portion of lost bags by American Airlines. Second one, second group, was proportion of lost bags by, how about Delta Airlines? Okay? What are our requirements? We've seen this before, but this time they stated random. So I will put random is stated. How many successes do we have? Well, 22 is greater than 5, and 15 is greater than 5. That is our successes, right? How many failures do we have? Well, the rest. So 5,000 minus 22, 4,978, which is definitely greater than 5. And 4,000 minus 15, how about 3,985? Also greater than 5 failures. So once we have the PR, we're ready for the, but my test this time is not a hypothesis test. It will be a 2 proportion Z interval. So menu, stats, I'm not going to go to test this time. I'm going to go to intervals, and it is a 2 proportion Z interval. How many successes were there? We said 22 out of 5,000. How many failures? Or, I'm sorry, how many successes for the other group? 15 out of 4,000. And did they give me a confidence interval? They said 95%, so that's what we use. And I want to know if there's a difference. What do I need to write down? If you're not sure, write it all down. But all we really need is the lower and the upper, okay? Negative 0.002 to 0.003. Now, these are small proportions. Keep in mind, they don't lose that many bags. But the question is there a difference between these two companies? Well, what's in our interval? If it goes from negative to positive, that means 0 is in our interval. That means we believe there is, not that there is no difference for sure, right? But you say, I am 95% confident that what? The difference, that P1 minus P2, the difference in the proportions is between negative 0.002 and positive 0.003. What does this actually mean? Since 0's in there, there is potentially no difference. Okay? Drug Clarinex is used to treat symptoms from allergies. Clinical trial 2.1% of 1655. Experienced fatigue. among 1652 given a placebo. 1.2% experienced fatigue. Construct a 90% confidence interval, okay? Is there a difference between the placebo and the clinical trial? See, a lot of times, a lot of these medicines, they work, but then they have to list all these side effects, right? Well, if they can show that there's really no difference between people taking a sugar pill and getting the side effect and people taking the medicine and getting a side effect, then they don't have to report it, okay? So, P. We're dealing with proportion of, subjects experiencing fatigue with, our first group was Clarinix. Our second proportion of subjects experiencing fatigue with, what's the second one? Placebo, right? Requirements. It said in the trial, treated subjects. Nowhere in there does it say it was random. So I will assume randomness throughout this test. If later on I find out that they didn't assign these randomly, then that makes this whole research bogus. How do we get normality? I need at least 5 successes, 5 failures. They didn't tell me how many, so I got to do 2.1% of the 1655. 0.021 of the 1655. So not 34.755 people. How about 35? Which is greater than 5. Okay? While I'm here, this will be our successes. I can probably calculate the failures at the same time. So that would be 35 out of 1655. That would be the other 1620 non-fatigue people, right? Here they had 1.2% of the 1652. Did I do that right? Yeah. So 1.2% of the 1652. I did not have 19.824 people. Probably closer to 20. So if 20 of them experienced fatigue, the other 1632 did not. PRT, what test are we running here? How about a 2 proportion Z interval? Don't need to state hypotheses because we're doing an interval here. So menu, statistics. What are we doing? An interval, 2 proportion. How many successes did we say we had? 35. So this wasn't a waste of time. We need that. 35 out of 1655. How many successes did we have in the second group? How about 20 out of 1652? But be careful, because they did say to do a 90% confidence interval. So change that to 0.9. What do I need to write down? Lower upper, 0.002, 0.016. I am 90% confident that, what do we do whenever I do a confidence interval? The difference in the means is between 0.002 and 0.016. So the question is, was there a difference? I should have the word and between those. Was there a difference? Well, both of these are positive, right? So yes, there is a potential difference. In fact, I would go further and say the fact that it's all positive implies P1 is greater than P2. Taking this medicine means you will experience a higher proportion of fatigue. This is a side effect they need to list. Okay? Last thing, and I've kind of alluded to this before. We've talked about this, but I kind of left this pretty simple. Now we're going to kind of kick this up a notch. How does significance level relate to the confidence level? Okay? Well, if I do a 95% confidence interval, or I'll just do 90 because that's what we just did. Okay? Well, what that means is that there is 90% is on the inside. If I'm doing a one-tail test, then that doesn't relate directly, does it? So if I do a 90% confidence interval, right, then basically this tail relates to this. So there's 10% left on the outside, but this wouldn't each be 10%. This would be, if this was 10% on the left, it wouldn't match this. This is basically 90% on the inside means 5% on the outside, right? So each tail would represent a 5%. Those would directly connect, okay? So if they give me an alpha, then the confidence level, if it is from a one-tail test to a basically a confidence interval, which is always a two-tail test, then it will be 1 minus 2 alphas. So a 5% tail would relate to a 1 minus 10% or a 90% confidence interval. If alpha equal 0.05, that would relate to a 1 minus 2 times 0.05. That would relate to a 90% confidence interval. If alpha was 1%, 1 minus 2, that would relate to a 98% confidence interval. I've talked a little bit about relating these two, but this is going to be a little more exact, and it'll be in the homework. Here's the good news. A two-tail is much easier. Why? Well, a two-tail splits the alpha onto both of these sides. So my alpha, each of these is alpha over 2, alpha over 2, okay? So it splits the alpha. Well, how does that relate to a confidence interval? Well, confidence interval is just the inside. So if they give me an alpha, then this ends up just being 1 minus alpha. So if it's a two-tail test and the alpha is 0.05, then this ends up being 1 minus 0.05 or a 95% confidence interval. They relate directly because two tails, this when I do the percentage on the inside has two tails. Okay, so let's abbreviate that. Let's just make a little box. What can I put on my note card? If it's one tail, and I'm given an alpha, 1 minus 2 alpha is my confidence level. If it's a two-tail test, and they give me an alpha, 1 minus alpha is my confidence level. So that's kind of your put on a note card, take it to the bank. Let's see if we can use it. Use a 1.01 significance level, by the way that is an alpha, right? Test the claim that ginkgo is effective in reducing the rate. Reducing the rate implies what is my test, right? My proportions, if I'm reducing, I'm lowering. This is not a two-tail test. Less than is a one-tail test. right? So what confidence level would relate to this? Well, one tail said 1 minus 2 alpha. 1 minus 2 times 0.01. 1 minus 0.02. This would be a 98% confidence level. Test the claim survival rates are the same. The same doesn't imply greater or less than. It implies what? Well, are they different? If equal to is the claim, then not equal to. This would be a two-tail test. They did not give me an alpha level, right? If they don't give me an alpha level, we would use 0.05. So, what's my confidence level? Well, two-tail is just 1 minus alpha. So 1 minus 0.05, 0.95, or a 95% confidence interval. Use a 0.05 significance level. There's our alpha. Statistically, men have a higher mean body temperature than women. Higher means what? Well, our alternative. Now, I'm not talking about rates or proportions. I'm talking about means. So it'd be mu is greater than mu2. We're comparing the means. This would be a one-tail test. So if the alpha is 0.05, the confidence level is 1 minus 2 times 0.05, 1 minus 0.10, or a 90% confidence interval. Test the claim. Flight 1 and Flight 3. That was not helpful. Maybe that'll work now. There we go. Flight 1 and 3 have the same mean arrival time. They give me an alpha. The same means my alternative is not the same. Two-tail test. 1 minus alpha. This would correlate to a 95% confidence interval. 0.01 significance level. Test the claim that the New York police and LA police have the same proportion of hits. Same means what? Not greater, not less. We just want to see. I need to change this because it said proportions. Right? So, not equal to 1 minus alpha, 1 minus 0.01, or a 99% confidence interval.